Okay, good morning everybody. This is the first tutorial. This is the first Hangout tutorial on the topic of computer security. Particularly, we discuss the topic of cryptography, and even more particularly, the use of Octave environment to solve cryptographic problems. So today, you will learn how to get started with Octave if you never dealt with this software before. Just to give you a bit of introduction, Octave, it's an open source alternative to the well-known engineering software called MATLAB. They have the compatibility in scripts in the range of greater than 90%. And the only big difference between commercial MATLAB against the open source Octave is that MATLAB is supported by the community of software developers who actually receive support for that. And they've developed a library of toolboxes that are not available in Octave. Rather than that, majority of the functions is still the same, and moreover, Octave also allows the mechanism of installing and developing and installing toolboxes, they call it packages, to actually mimic full functionality of the MATLAB environment. So today I will presume that you work on Windows environment and moreover Windows 10 environment, and there are a number of ways of how you can get started with Octave in here. Probably the easiest one would be just to install Octave environment on your Windows 10 machine. And so you just want to Google Octave for Windows. And go to download page. Click on Windows. Follow the link to FTP server. And scroll all the way down to the latest version. I presume that you have Windows 64-bit operating system, and you want this installer called Octave 421W64 installer. So 421 is the latest version of the Octave. It was released back in February 2017, so it's relatively new version. But if for some reason you have earlier versions of Octave, scope of our course doesn't really require you to deal with the latest version. So earlier versions are also okay. If for some reason you can't install it on your own computer, or if you, for example, don't have Windows operating system, but for example have a Linux or Mac machine, it's probably not going to be that easy. Actually, on Mac, it's still relatively easy because Mac has support of third-party applications via Mac ports and Brew systems. If you currently working on Mac, you should know about this. If you need more assistance, just send me an email and I will help you to install Octave on Mac. And if you work on Linux, you likely will need to compile Octave from sources. This is not the easiest task to do, but it is still possible. And once you will install Octave from sources, you will have the fully functional system. So in situation that for some reason you cannot or not going to install Octave on your own machine, we offer a remote system, remote server with Octave pre-installed, and you will simply need to connect to that remote system. You will need to use basic skills in Linux environment. I know some of you have already taken Unix course CSI 3200. If you didn't have a chance to take it, probably you will just need to learn a few basic operations, and today I will show you several of these operations. The only open question, how to connect to this Octave remote system. When you work on Windows, you will need an SSH client. If you work on Linux or Mac, you already have SSH client. SSH client is a program that can be used to actually reach to remote system, and the most common SSH client on Windows, it's called PuTTY. So you just Google for the PuTTY and go for the download link, and another click, and since they changed it a bit, you actually can stick with the Windows installer or just start the standalone PuTTY application. So I suggest you to download the 64-bit version of PuTTY, store it somewhere on your hard drive, probably in downloads folder. And once it will be downloaded, you just want to start it. So that is the window of PuTTY software. And to connect to our server, you want to type Octave, jswcm.net in the host name. Octave, jswcm.net. You want to keep port number 22 without any change, and just click the open. It will be displayed with the security alert message. Pretty much it states that this is the first time you reach into this remote server, and it actually says that, do you trust to this remote server? This message actually is displayed when you reach to some remote server for the first time, or if you already work with the remote server but the fingerprint of that remote server has changed. Could be because of some changes made by system administrator, maybe because due to some changes made by attacker. So the fingerprint of the remote server may change, and PuTTY, as being an SSH client, will detect this change and will display you the message that probably something wrong is happening. So since this is our first time to connect to Octave remote server, we just accept it, and it asks us for the username. You want to use your JSWCM credentials. If you don't know what it is, you can go to our wiki page, and there is part of this page for students, and few words about user accounts. So basically, your username is your D2L username, wherever it is, and your password, if you didn't change it, it's last 6 digits of your JSW ID number. If you have taken Unix course, you likely have changed your default password. If you don't remember, change it, so it is last 6 digits of your JSW ID number. So let me use my credentials. No, not here. Okay, I got disconnected because of timeout, so I want to restart the session. So now I'm connected to the Octave server and I'm ready to work. All right. So I'm not going to continue right at the moment because I want to show you another way of how our remote server can be reached. It actually can be reached without dealing with PuTTY SSH client, because with the latest version of Windows 10 environment, there is integrated support of Linux shell called bash that you actually can activate in Windows. To do this, you want to go to the settings, just hit your start button, start typing settings, and then in updates and security, you will have developers option. You want to activate this radio button. Once this radio button is activated, you want to go again to the start menu and actually right click on this and start the control panel. In the control panel, in the programs, you want to choose turn Windows features on and off. And you want to scroll this list down and put a check against Windows subsystem for Linux. So I'll put a check mark here and hit OK. In my case, the system is already activated. So I'm not going to hit OK. I just clicked on cancel. But you will likely be prompted to reboot your computer. So please do it. And after reboot, in the start menu, you'll have the bash on Ubuntu on Windows. I have it in my taskbar. This is here. And that's pretty much Ubuntu operating system running within Windows environment. Why do I need this? Simply to access SSH client, which is a built-in component of any Linux distribution. So in this case, instead of using PuTTY on Windows, I can use SSH client, which is now integrated software in Windows. And SSH, that's the name of the program. And now I want to type the username and Octave with wcn.net. And I will be connected to this remote server. So my account is set in such a way that I can log in without entering the password. You will likely be prompted to enter the password. So please do it. And again, you will come to our Octave system. Now, once you are there in our Octave server, to start Octave, just type Octave. Okay, and here is the Octave environment. What can we do in Octave? The question is actually not about what we can do, excuse me, but the question is what you will have a chance to learn about Octave. Because Octave is highly used in engineering society, in computer science society, very little in IT society, to perform various different kinds of calculations. And the basic idea of Octave, it has two modes of operations, interactive mode and scripting mode. Interactive mode of Octave allows you to pretty much execute some statements, arithmetical statements with very forgiving syntax, and it will just calculate you the answer right away. You can actually introduce variables and reference those variables by value. you can introduce another variable and use variables now a and b in an expression. Moreover, I will probably say moreover several times, we can introduce not just plain or scalar variables, but vectors and matrices. Matrix is considered to be a two-dimensional array. Vector is considered to be a single-dimensional array. I hit Control L to clean up the screen, just to start from the very top of my window. So a vector, let me call it V, and I can say my vector will have these four numbers. Why do I need vectors in Octave? The big reason for using vector is that sometimes you just want to store a range of numbers and consider them for operations as one whole thing. And you will learn how to use vectors to actually solve our cryptographic problems in my next tutorial. If you want to create a two-dimensional array, I want to introduce variable m. You need to create all rows of that matrix. And let me just create a matrix of dimension 2 by 3. So a space is a separator between entries of the same row, and a semicolon is a separator between two different columns. So now I have two rows, a matrix that contains two rows with 3 columns in each row. I can go ahead and actually redefine this matrix by creating another row. What can we do with matrices? I suppose that you touched this topic in a discrete system course. If not, matrix is actually a very universal thing, and you can do a lot. You can solve linear algebraic equations with matrices. You can multiply matrices. You can add matrices. You can inverse matrices. Let me just demonstrate how determinant of a matrix can be calculated in Octave. So that is a function, predefined, pre-built function in Octave, and I just use the calculator. So I just use it to calculate the determinant. Now, there is another way of how you can create ranges in Octave. Actually, there are a few more ways. And I also want to mention that there is no real need to set up a variable to store the value. Sometimes I just want to display a range of numbers, and that range of numbers will not be stored in a variable. For example, I can create a vector from 1 to 6. It is temporarily stored actually in a variable named ans. If I just repeat variable ans, it will be replicated over and over again. But should I execute some other statement, variable ans is no longer that vector, but as a result of my last operation. So if I just want to display certain sequence, I don't allocate a dedicated variable for that. If I don't need to store it in a variable, if I do need to store it in a variable, then I can do something like this. So in this case, instead of just specifying the start and end of the sequence, I specified start, end, and the step. In my case, 3 is the step, so my sequence is 1, 4, 7, and so on and so forth, till the very last entry, which is 100. So that is yet another vector. And actually, there is a good way of learning what kind of variables you already have in your Octave session and to actually see these variables at once. There is a command called whos. It shows you the summary of all variables and their dimensions. For example, variable A is a scalar variable because the size is 1 on 1. Variable B, it's not a scalar. Variable M is a matrix 3 on 3. Variable V is a vector 1 on 4. So the first index is number of rows. The second index is number of columns. For example, variable double A in this list is a vector 1 times 34. So it is 1 row, 34 columns. A vector in Octave is not necessarily laid in the shape with 1 row and multiple columns. For example, I can transpose a vector by adding an apostrophe at the end of the file name, at the end of the variable name. In this case, now my vector has multiple rows and a single column. It is still a single dimensional array. It is just shaped differently. So I can say that BB will be a apostrophe, and here it is. Now, if I repeat the who command, actually whos, who command without s at the end simply displays you the variable names, but who with s at the end displays you list of variables along with their sizes and data types. So double A here is 1 times 34, double B is 34 times 1. It's exact same data, but shaped differently. Now, if I want to use these vectors A and B, probably the easiest thing to do this would be to visualize vector A. There is a function called plot, and without having any graphical front end, Octave prints all graphics in the text mode. We know that A double A is actually a sequence from 1 to 100 with a step of 3. That's why it is always monotonically increasing function. But instead of just creating an increasing monotonic function, I can create a sequence AA from random numbers. Random number actually accepts 2 arguments. Actually, it can accept a single argument, and it will create you matrix on, if it is just single number M, variable M, it will create you single matrix 3 on 3. So if it was, instead of 3, if it was 5, it would create 5 on 5. Each entry in this matrix would be less than 1, and this is pseudo-random numbers. So, but I can also define 2 numbers, for example, 1 row and 100 entries. So in this case, my double A now is shaped as 1 row and 100 entries. And I actually can plot it. And here is the plot. So it is random sequence from 0 to 100. Indices of that sequence is along the x-axis, and the values are along the y-axis. You can add a grid to this plot. You can actually switch grid by issuing it twice. And you can do some other things with the plot, which we will talk about later on. But as I said, plot is the easiest way to visualize your data. Now, Octave has also very good feature for filtering of data and actually searching of data. For example, in my array AA, let me do some manipulation with this sequence by multiplying it by 100, because right now all these numbers are less than 1, if I multiply it by 100, at least they will be arranged from 0 to 100. I know that the original sequence was arranged from 0 to 1. If I multiply it by 100, now all my numbers are arranged from 0 to 100 instead of from 0 to 1. And I also want to cut the fractional part of this. And if I'm not mistaken, it is a function called floor. Yes. So Octave actually deals with vectors and matrices in pretty much exact same way as how it deals with scalars. So I can create B by applying function floor over AA times 100. So AA is a vector. When I multiply it by 100, it actually multiplies each entry of the vector AA by 100. And when I do floor of this, it applies floor operation to each and every entry in the array AA. Right? And here is the sequence, random sequence from 0 to, in the range from 0 to 100, and size of that sequence is 100. By the way, when you work in Octave, not always you want to immediately see a result of the last operation. If you want to suppress the output or result of the last operation, you want to add semicolon at the end. In this case, operation will take place, variable will be assigned if there is a variable, but result will not be displayed. So you know that a variable can be referenced by name, and here it is. Now, if I plot BB, here's pretty much the same shape, but the numbers on the y-axis are different. So my vector BB, let us try to filter it. Let us try to find those entries that are greater than 50, for example. And you'll be surprised, but the way how we can find something in an array would be just to compare an array with a number. So I'm writing condition where on the left-hand side, actually, not necessarily on the left, it could be on the right, but it is the logical condition. A logical condition that compares a vector with a number, and I said earlier that Octave treats this operation on per element basis. And pretty much it evaluates this condition for each and every entry in the original data set. For example, 49 is greater than 50, no, the result is 0. 15 is greater than 50, no, result is 0. But 66 is greater than 50, result is 1. If you wonder how can we use those zeros and 1, there is actually a function called find that can be given with that sequence of zeros and 1s. And it returns the indices of all entries that are not 0. This is how we do filter. Since we have all indices, we now want to apply that set of indices against the original array. And since double B, it's nothing more but a matrix, it's nothing more but an array, we actually can get I'm always getting this part. You actually can reference any entry from the vector B by index. It could be 1, it could be 10. Oh, BB of 10, it's 42. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That is 42. We confirm this. The interesting thing is that indices in Octave start from 1, not as in Java or C# programming languages where indices start from 0. they start from 1, and this is just to follow the pattern of MATLAB environment. A long time ago, when MATLAB was developed, it was early 80s. The first version of MATLAB was developed, actually mid 80s. They, for some reason, decided that indexes have to start from 1. So that's what they did. And in other words, BB of 0 subscript must be either integers from 1 to something. So in other words, it doesn't allow index of 0. But a good thing about Octave is that it can use index which is a vector. So for example, if I want to retrieve the first, the third, and the fifth entries of the array double B, of the vector double B, I want just to apply the index in form of a vector. And that gives me the first entry, the third entry, and the fifth entry. So the first is 49, the third is 66, and the last one is 67, which is the fifth. So, and that's actually how our find result can be used. These are the indexes of all entries in that array that are not zeros. But those zeros and ones actually correspond to the condition BB is greater than 50. So combining all together, we can just write BB of find of BB greater than 50. And the index, the way you want to use parentheses. So these are the entries in original vector BB that are greater than 50. How many of them you actually can calculate this? There are 57 of them. So the function size determines the size of the vector. We know that this is the vector of one row and multiple columns. That's why it is one row and 57 columns. If you don't want the two numbers, you actually can use the function length. And okay, instead of size, you want to use function length. So 57 entries in that array are greater than 50. We can plot them. And again, let me actually store this result in a variable cc. Now I can easily reference this by name cc. So as you can see, all numbers are greater than 50. This is just a confirmation. Now, we can actually save some data to a file and actually read those data back into Octave session. The way how you do this is by means of utilizing save command. Save command, if executed without any statement, without any options, tells us, gives us the error message, and this error message actually contains the help information. So at least it requires you a file name. If save is given only with a file name, it will save all variables. If you need to save specific variables, you want to provide save, file name, and then the list of variables. So for example, I want just to save BB and CC, actually AA, BB, and CC. I would say one, AA, BB, CC. The order here is not important because it is just a file, a text file. And actually, it is not just a text file. Let me show you what it is. So once we created this, and let me now start another session to actually see that file. Okay, wait. Something wrong with my recording. Okay, I hope YouTube still does record this. Okay, now I want to SSH to Octave again. And I can list the files in my directory. And here is my file take one. I can read the value. I can actually display content of this file. And here you can see that there is the content and some description of that file. Original AA, and then BB, and then CC. So it's probably the next question, how can we use that file? Back into Octave, we can execute clear statement. Actually, clear all. And clear statement will just remove everything. So whose now shows nothing. In other words, we removed all vectors from the memory. And if we want to read a file, we use load command and the file named take one. Execute whos, and now we have restored our variables AA, BB, and CC. Okay. Now, what if you want to transfer these files back and forth between our Octave server and your Windows machine? There are a number of ways of how you can do this, and I believe the easiest one would be to install a special piece of software called SFTP client. One of them is called FileZilla. It's an open source software. You just search for FileZilla and download FileZilla client. You want to go ahead and start downloading for Windows 64. Okay, I'm going to save the installer. And once it is downloaded, I will start it and will install FileZilla on my computer. I accept default options. Okay, so FileZilla basically has two panes, the local files and the local system and the remote system. Here you can navigate through the path file system in the local computer, and here will be similar tree on the remote system and the list of files in the remote system. So we already know that the host name is Octave is wcm.net. Username in my case is this. My password. And don't forget to specify the port number, which is 22. You remember that party was guessing this port number. Here you have to specify it explicitly. quick connect. I don't want to save my password. And it got connected. That's the directory structure on the remote server. And this is the list of files. You can see more files compared to what you've seen in the shell, because in the shell we just had the cloud and take one. Here we can see way more, particularly we see cloud. And those files that start from a period, they are called hidden files. They're actually there. They are not just visible in my normal session. If I use ls command to list files and provide a command line option, I will see them all as well. Without a, I can just see those files without a period at the beginning of the file name. And that is my take one. So what do I want to do with this file? I probably want to copy it to download. So I open download on my left pane, and you can drag it, and here is your file. You now can open it in some editor, Notepad, Sublime, Notepad++, any editor you want. When we will start working with Octave scripts, we probably will do the development on the Windows side using some fancy development editor. And once we will finish creating a script, we will copy result to the Linux server, to the Octave server, and we'll execute it there. So not only a file can be transferred from remote to local, but it also can be transferred from local to remote. And just to demonstrate this, I can probably copy a PuTTY program to my Linux server. So once I've transferred it, here I have the PuTTY on the Octave server. Right? So that's pretty much the basics of Octave, the way how it works, the way how you can work with Octave. And there will be more tutorials on actually how you can use Octave to break the different cryptographic algorithms. We'll start with pretty easy cryptographic algorithm called Caesar. Our webpage on D2L has some information how Caesar cipher can be broken. And just stay tuned. I will make another announcement for the next tutorial, and we'll continue in the same way. All right. So I hope you enjoyed this video, and let me stop the broadcasting. And where it is. Okay. Thank you for watching.